Okay, so I like to work the problems and show you how I go through working the problems that we have are going to be on the quiz or stoichiometry. And in this case, we are working with limiting reactant and reactant in excess and how much. So I'll try to slow down a little bit. Some people told me I needed to slow down, so I'll slow down a little bit. First, though, we want to either name or write compound structures, okay? So right here we have a name, calcium carbonate. And so we want to write the structure for calcium carbonate. And in this case, we know we have calcium, and carbonate is not an element. Carbonate is actually on the it's on the reference table for polyatomic ions. So calcium is going to be Ca, and carbonate, calcium's right here, Ca, and carbonate is on the back here, and carbonate is CO3 2 minus. So I'm going to put CO3, and then I'm going to put a -2 above that to remind me. And then I want to look at calcium and say, okay, so what is the charge on calcium? Calcium is in this second column, so anything there is pretty much a +2. So that's going to be a +2. So calcium carbonate is just CaCO3. All right, the next thing is SB. Ooh, SB is one of those weird ones that doesn't. I don't have the name of it here, but SB is called antimony. And it is in that area that we're going to now do prefixes for instead of charges. So in this case, we have antimony and it's oxygen, so it's going to be oxide. However, since there are 5 of them, we got pentoxide. So antimony pentoxide is the name of that one, and that comes from the right-hand side of the table when you use the prefixes. And then the last one is aluminum, and we see aluminum right here. And sulfide is going to be just sulfur, so it's aluminum and sulfur, aluminum and sulfur. And you look at aluminum, and aluminum is always a +3. And sulfur is in 16, and all of these are -2, so this is a -2. So we've got +3, -2. We're just going to flip those and make it Al2S3, and that's the 3 things at the top, okay? Let's zoom in a little bit so we can see the first question here, all right? Okay, so the first question is 15.41 moles of O2 are reacted with 6.3 moles of B2H6. So I know that it's 15.1 of this. Let me see, O2 is 15.1 mole, and we have 6.3 mole of this. So we want to find out on this, since this is limiting reactant and excess, we want to find out which one is limiting and which one is excess. The easiest way for me to do it is pit them against each other. Start with one given and work towards the other given. So for me, I'm kind of a simple person. I'm just going to start with the first given, which was 6.3 mole B2H6. And then, remember, it is given, unit convert, 3 is mole convert, no, compound convert, and 4 is unit convert back, if you need it. In this case, since we start with moles, we don't need the unit convert. These 2 are only if needed. 3 is going to be a definite. So I'm going to immediately put mole B2H6 down here, mole B2H6. And I'm going to then work towards the other one, which is mole O2. Okay? Since it's mole and mole, we know we're talking about the mole ratio, so we're going to go up to the equation or reaction, and we're going to put a 3 in front of that from the O2 and a 1 in front of the B2H6, and then we're going to cancel out. And then I'm just going to do the math on this, and what I find when I do the math is 6.3 times 3, and that gives me 18.9 mole O2 needed to use up all of the B2H6. I have 15.1 mole O2 on hand. So since that number that I need is higher than what I have, that means that the oxygen is going to be the limiting, and B2H6 is going to be excess. So I'm going to underline that and circle limiting, and that's the O2. Okay? So the next part of it is to find out how much excess there is. So I'm just going to flip it. And now I'm going to find out if I use the 6.3 mole O2 and it's 3 mole O2 to 1 mole B2H6, then I get 6.3 divided by 3, and I get 2.1 mole B2H6 needed. On hand, I have 6.3 mole B2H6 on hand. So if I subtract it, it's 4.2 mole excess B2H6. And that is my answer to that one, okay? So nice and easy, find out which one is limiting and which one is excess. And then with the excess, find out how much excess you have left over, okay? All right, the second one is 30.2 liters of O2 are reacted with 2.83 moles of carbon. And here's my reaction right here. It is already balanced, and I'm only working with going from one of these to the other. In this case, again, I'm going to go from the oxygen because that's the first one that's here. 30.2 liters of O2. And I know that 22.4 liters of O2 is in 1 mole of O2. So that's going to be my unit conversion right there. And then I also know that I'm going to put mole O2 here because it's here. And I'm now going to my compound conversion, which is going to C, mole C. And I have 2 moles of C from the balanced equation to 1 mole of carbon, 1 mole of oxygen. And then I want to go, okay, well, what do I want to go to? I only want to go to moles of C, so I'm actually done because I'm already finding moles of C. So in this case, I'm going to do 30.2 times 2 divided by 22.4, and I need 2.70 mole C to completely react. Well, how much do I have? I have 2.83 moles of C, so that one is in excess. Because I have 2.83, I only need 2.70. This is nice because I have 2.83 C on hand or in inventory, however you want to call it, and is 2.70 C needed for reaction. And I'm just going to subtract that. So 0.13 mole C in excess. And that will be the answer to that. All right. Now that time, you notice I chose the right one, whether I did it purposefully or not. I didn't. I just picked the first one. Okay. So that one I only had to do it once. This one I had to do it twice. Okay, the next one we have here. The next one is 2.97 moles of H2. So we're going here, and 52.7 grams of CS2 is right here. So I'm going from moles to grams. It doesn't really matter. I'm going to start with the 2.97 mole H2. And since I'm starting at mole now, I'm just going to go directly to the other mole OH2, whatever's here goes here. And I'm going to transition to my new compound, which is CS2. And it's going to be 4 mole H2, 1 mole CS2. And I know that in 1 mole CS2, there are how many grams of CS2? Now, in this case, I do need to work it out. So I know that C is 12.01 and S2 is, if you look at sulfur here, it's 32.06. That's 32.06 times 2, which is 6412. So if I add 6412 and 12.01, I get 76.13 grams of CS2, and that is the molar mass of it. That's all I looked up. Okay. Now I'm going to cancel out to make sure I know where I'm going, and I'm supposed to end up with grams of CS, which I do. So now I'm just going to 2.97 times 76.13 divided by 4, and I get 56.5 grams CS2. I have 52.7. So because of that, I don't have enough CS2 to complete this reaction. So that makes this one, CS2, the limiting factor, which we're going to circle here. And we're going to put this as the excess reactant. But now that I did that, I have to switch things. I have to start with the CS2 and go back to the H2 to find out how much excess I have. So I'm going to go down here. I'm going to start with my 52.7 grams CS2. I've already done the work for it, so it's not going to be as bad. I know it's 76.13 grams CS2 in 1 mole CS2. And then I also know that 1 mole CS2 is 4 moles of H2. And I cancel those out. Okay. Now I get 52.7 times 4 divided by 76.13. And I get 2.77 mole H2 needed. I have 2.97 mole H2 inventory. And so I end up with 0.20 mole H2 excess. And that's how that works. All right. I first found out that it was, let's see, okay, I'm going to do this one. So I first found out that the CS2 was in excess, and then I had to go back and find out how much excess it was. Okay. And then the last one we have here is we've got 170 grams of P4, 173 liters of H2. So we're going to go one of these two, and I have 170 grams. I have 173 liters. And so I'm just going to start with the grams. 170 grams P4. And I can just look this up. This one's not too bad because it's P, and P is 30.97. 7 times 4, and that's going to give me 123.88 grams P4 is in 1 mole P4. Okay. Now I'm automatically going to put mole P4 here. Cancel these out. And I'm going to now transition to my new compound, which is H2. And the number in front of P4 is 1, and in front of hydrogen it's 6. So I'm going to liters, so I need to do 1 more. I need to do 1 mole. Hydrogen is 22.4 liters of hydrogen. And cancel that out. And then I think, okay, 170 times 6 times 22.4 divided by 123.88. And that is going to do it for me. 184.4 needed. 184.4 liters of H2 needed. Well, guess what? We only have 173 liters of it, so we don't have enough hydrogen to use up all the P4. So I'm going to redo this whole thing because I need to find out the excess of P4. So I'm going to start with my 173 liters H2, and I'm going to go that 22.4 liters of H2 is 1 mole H2. This is my unit conversion. Then I'm going to go to my mole conversion, my mole ratio, H2 to mole P4, and it was 6 hydrogen to 1 of those, P4, and then I'm going to do 1 mole P4 is, I say 123.88, 123.88 grams P4. And now I just do the computation. It's going to be 173 times 123.88 divided by 22.4 divided by 6. And I get 159.5 grams P4 needed. And on hand, I have 170.0 grams P4 on hand or in inventory, whichever you want to call it. And I'm going to subtract 159.5 from 170, and I get 10.5 grams P4 excess. And that is how that's going to be. Now, you only are going to have 3 of these on there. It won't be 4. So hopefully this is good. This is pretty much the same thing we did last week, only this time we've got 2 givens and we are comparing them with each other. All right. I hope that helped. Good luck on your quiz, and I will see you soon.